So for number 1, you need to remember that the margin of error is equal to the critical value times the standard error, which is p hat q hat divided by n. And so I'm going to write 200 instead of n because they told us 200. All right, and so now what they're saying is 1/5. So if I put 1/5 here, I have to put 1/5 here, right? What you do to one side, you have to do to the other side. All right, so now what I want to do is I want to get the number inside of here. Now, because the 200 is inside a square root symbol and the 1/5 is outside the square root symbol, I'm going to have to square it to put it inside. Yeah, I don't like this color, so let me go to something darker. We'll go to dark green. All right, so then it's going to be equal to, so 1/5 of my margin of error is going to equal to my critical value times p hat q hat divided by 5 squared times 200. Well, 5 squared times 200 is 25 times 200, which is 1,000. So the answer is 1,000. Okay, let's go to number 2. What is true about a 99% confidence interval? It says the interval contains 99% of the population. That is not correct. Results from 99% of all samples lie within the interval. Okay, that should be true. The interval is wider than a 95. That is true. So I'm going to say 2 and 3. So the answer is E. Okay, so what do we have here? We say we have 34%, 190. All right, so what I'm going to do is going to go put this into my graphing calculator. All right, so since they said 34% out of 100, that means my successes are 34, my sample size is 100, and it is at a 90. Now my calculator, I get 2621, 2.4179. So which one would that be closer to? 261, so the answer is C. Okay, for a large sample, the size of the distribution mean is always normal. All right, so we haven't really talked about this, but let's think about this. Remember back in first semester when we talked about the law of large numbers, that as we have more and more trials, that we get closer to the truth. Okay, well, same thing goes with normal distribution. The more and more samples we take, the closer we get to a normal distribution. Okay, you need to know for number 5 how all the variables work in playing with a confidence interval. So we're talking about as n increases. So let's just take an example. 1/2, so n would be equal to 2. 1/3, n is now equal to 3. So what happened to my fraction? My n got bigger, but what happened to my fraction? I went from 50% to 33%, so my fraction became smaller, right? So that means the standard error will decrease. So if everything else is the same, and my standard error is decreasing, then my interval will decrease. Okay, now let's talk about margin of error. Okay, the margin of error increases the standard deviation, and I should write standard error there. Okay, so what do we know? We know that the margin of error is equal to the critical value times the standard error. So if the margin of error is increasing, okay, this critical value stays the same, So that means my standard error will also increase. Okay, as the confidence increases, the sample size blank in order to maintain the same standard, the margin of error. Okay. Okay, as the confidence increases. All right, so 90%, after a while, you begin to memorize these. That's 1.64. 95% is 1.96. All right, so I know that as my confidence interval increases, my z-star increases, right? So if my increase, okay, but it says the sample size must do what in order to maintain the same deal? Okay, so if I want to keep my same margin of error and my critical value is increasing, then that means my standard error must change, must decrease. And how do I get my standard error to decrease? And that is to increase my sample size. Remember from back up here. So we will increase my sample size. You might have to think about that one. Okay, let's go to number 7. I'm going to change my pen. Okay, it says a 99% confidence interval for the mean reaching a score for a population of third grade students is this, the sample mean. Okay, so let's think about it. I like to think about this as a number line. And I got my lower bound and I have my upper bound. And in here is my p hat. Okay, and this is my margin of error. Okay, so do you see that's the midpoint? And the formula for the midpoint is the same thing as the average. You add the two numbers up, and then you divide by 2. So what do I get? I get 49.2. So my answer is C. Okay, number 6 is a little bit lengthy, so why don't you read it? Basically, they want to know what is meant by a margin of error. And I recommend that you would read about this in the book, okay? But the answer is E, okay? Has nothing to do with the fact they are using telephones or the telephones don't work or whether or not people knew about anything. It has to do with statistics. Okay, so we have a 95% confidence interval is this below, and they want to know which of the following is correct. Well, if we have a 99% confidence interval, my z-score increases. So if my z-score increases, my margin of error increases. So I know that A is wrong, B is correct. The intervals do not have the same width, and you cannot determine it. The answer is B. Okay, number 9 is just another way to say what is meant by a confidence interval. And 408 divided by 865 does equal to 0.47. All right, but it's not that just because that's my p hat doesn't mean that they all are in favor. And it's probably true. No. Okay, remember, we don't know anything. The answer is D. We are 95% confident that between these two percentages of voters in Delaware favor an issue before this legislature. That's the answer to D. Okay, so they want us to do a confidence interval of whose support. And that would be 4. Okay, so this is basically about conditions. And so what do we know? Okay, it says it's random. All right? And we can say that 100 is less than 10% of all residents. Okay, so the first two conditions are met. So it must have to do with success fail. So let's do successes. Do you see that 4 said yes? 4 said yes. and 4 is less than 10, and why does it have to be greater than 10? So the answer is D, is too small.